Thank you so much for joining our panel on intelligent autonomy for manufacturing. My name is Dan Radomski. I'm the CEO of Centropolis Accelerator. I manage North America's only Industry 4.0 accelerator. And what that accelerator does is it tech scouts globally for the best I4O solutions, whether it's robotics, IIoT, AI inspection technology, you name it. And we work very closely with corporate partners to bring these tech companies from all over the world into these manufacturers to help them adopt these technologies to improve throughput, quality, reduce manufacturing operating expenditures. We've been doing this for about 6 years now. We've had the luxury of working with wonderful tech companies that you're going to hear from and large manufacturers like Ford Motor Company. The panelists, I want to thank them for being with us today. We have immediately to my left, well, to your left and to the right, Wolfgang Hackenberg, who's the CEO and co-founder of Senios. We also have Tracy Perdue with VP of Sales with Wybotic. Amir Bousani, who's the CEO and co-founder of Argo Robotics. And Paul Stevens, the Global Strategy Manager for Autonomous Robotics from Ford Motor Company. It should be no surprise, being on this floor at Automate, that we're entering a new era of automation, right? And machinery that is not only automated, but it is becoming increasingly intelligent, adaptive, and autonomous in its operation. I remember, as being a kid, growing up as a machinist, being in manufacturing most of my life. Even 30 years ago, we were talking about lights out manufacturing and could we really get to full autonomy, intelligent manufacturing, and we're actually bridging into that area now. And the panel is really designed for us to learn from these leaders of industry that are really shaping how these technologies are deployed in operations worldwide, and learning from them what's working, as well as what the challenges are in implementing, piloting, demonstrating, going enterprise-wide with these technologies. So I'm going to allow our panelists to introduce themselves. I'm going to ask them to tell us a little bit about their company they work for, and a little bit about their company's involvement in intelligent autonomy. So let's start with you, Wolfgang.
Why not?
There we go.
Okay, hi. So yeah, my name is Wolfgang Hackenberg. I'm CEO and co-founder of Synaos. We are a German-based startup, and we provide an intralogistics management platform. That means we are orchestrating everything within a warehouse, a factory, mobile robots, AGVs, AMRs, but also manual-driven vehicles and humans if needed. And I was 10 years with the VW Group, being responsible for shop floor IT and Industry 4.0. And out of that experience, we saw that software is the key for the future in manufacturing, in intralogistics, and that's why we founded Synaos. And yeah, we have the biggest partner network over the VDA 50/50 interface. I'm also in the board of the VDA 50/50 committee for mobile robotics in that interface. So we're going to talk about that, I think, today.
Yes. Great. Tracy, introduce yourself.
Thank you. My name is Tracy Perdue. I'm the VP of Sales for Wybotic, located in Seattle. We started the company in 2015, and we provide a central wireless charging infrastructure along with power fleet management software.
Great.
Hi, nice to meet you all. My name is Amir. I'm the CEO and co-founder of Argo Robotics. At Argo Robotics, we focus on enabling intelligent automation and enabling companies to adopt intelligent automation with AI. We focus on providing smart software that enables machines to see and to understand their surrounding. We call it visual perception, so enabling smart machines that can see and understand and behave more intelligently, and that's the topic that we'll talk about when we talk about intelligent automation.
Great, thank you, Amir. Paul?
Yeah, thanks, Dan. Really excited to be back here. I think I was here yesterday and shared a really good conversation with some other companies in this space. I'm Paul Stevens from Ford Motor Company. What I'm really excited about is being able to provide the voice of the customer on this panel to talk about what is the customer looking for as we go about an entirely new mission in bringing automation to create more value for our customers, higher quality vehicles, and overall deliver more satisfaction to our partners. And so a couple things that we're really interested in is hearing about what the technology is in the market and then how that can be applied to our challenges on the shop floor today. And when we bring together the problem with the right solution, it creates that synergy that we need to be successful as an automaker. Thanks.
Great. I'm going to kick off a few discussion topics, and then we're going to make time towards the end of this panel session to allow for some Q&A. So if you have questions, please reserve them to the end, and we'll pass around the mic and get your questions in for discussion. So I was hoping each panelist could address how they view intelligent autonomy, intelligent automation, as well as what's the real vision versus the reality. So let's start with you, Wolfgang, and go right to left.
Well, vision versus reality. As I said, Zunar is providing an interlogistics management platform. So we're orchestrating every vehicle, everything that is moving within the factory, the warehouse. And that was our vision from the beginning. And standards are very, very important for that, okay? Because we are not orchestrating only one robot or one forklift or anything like this, but all different in one layout, okay? And standards were very important, are very important, and this really needed to pick up over the time, okay? So as already mentioned, the VDA 5050 is a standard coming from Europe, now being widely spread in the US and also in Asia, is really helping to orchestrate all the different robots in one layout. So you can buy a forklift a robot, you can buy like a lifting table, a roll-on-roll, all of that in one layout. You can buy it from different manufacturers. And that is, I think, the vision, everything orchestrated in the back end with algorithms, with AI, always finding the right, the perfect matchup between an order and the resource that's supposed to do so we can reduce numbers of robots by 30 or 40% combined to traditional planning approaches. And I would say it's picking up. Customers are getting more aware of the pain points they have. A lot of started with simple automation, with different robot cases in different corners of a factory, of a hall or something. And now you have more and more overlapping routes, more overlapping maps, and you need central orchestration, and that's where we're at. And I think that vision is coming into life with all the different aspects.
Thanks. Tracy, I'd ask you the same exact question. What does intelligent autonomy mean to you, as well as the vision versus reality?
Thank you. So, obviously I'm going to be coming from a wireless charging perspective, but really my answer would be very similar to yours, Wolfgang. Just from a charging perspective. But, our vision was really, future-proof our customers' autonomous robotic infrastructure. And that vision is becoming a reality. A lot of companies are adopting it today. And if they haven't adopted it, they're already looking at it. But really the vision and the benefit of wireless charging is if you set up a wireless charging infrastructure within your facilities, you can now bring in any type of autonomous robot. It doesn't matter if it's an AMR, it could be an ASRS, it could be indoor AMRs, outdoor AMRs, it could even be floor jacks, it could be floor scrubbing equipment. Any autonomous vehicle with a battery can charge on the same wireless infrastructure. So there's a lot of benefits to that, and I'm sure we'll get into the benefits a little bit later, but interoperability is a huge one, and then there's also some safety benefits that go along with it.
Amir?
So I apologize that I have to be the bad guy at the panel, but I think the reality today is that automation is not that intelligent. I mean, it's very far than how intelligent it can be, and I think in a few years we'll see so much improvement in the level of intelligence that machines have. If you look today at how many employees are needed to install a robot, it's crazy. I mean, you want to bring automation, but there are many engineers required to install every single robot. What we really want to do is to make machines intelligent, and I think these days when you can see what ChatGPT and foundation model and generative AI can do, it's clear that machines are going to be so much smarter than what we see them today. Today machines are really, we call it programmed autonomy. So someone programmed every single behavior of that machine. That's great, but that's still not intelligent. What we will see, it will take some time, but it's coming. We'll see machines that are really powered by generative AI, by advanced algorithms, physical AI, that enables true intelligent autonomy. Machines that can install themselves, that can understand the environment, that can change their behavior based on changes in their surrounding, and that can enable true autonomy, enabling a efficiency that is way beyond everything that we see today, and it's not that far off. We'll see that within a few years.
And I think, Paul, it'd be interesting to hear your perspective, vision versus reality, right, in intelligent autonomy from a manufacturer of a complex set of automotive products. Tell us from your perspective.
Yeah, I love this question. It's really the difference between a futurist and somebody in an implementation mode. If you asked me that a year ago, I would have had a very different perspective when we had a very stable environment from a global trade perspective. Now, things have changed, and we have to plan for uncertainty, we have to plan for flexibility more than we ever thought we would have had to. So we were driving to an ROI model before. Now, right up there with ROI, and in a lot of cases, above ROI is resiliency. So how we get there is we invest in incredible, flexible systems that have the ability to take in a lot of data and react in an intelligent way to what's going on the shop floor. I love the question too, because I have vendors come in my office every day trying to sell different solutions, trying to present their vision for intelligent automation and to the future of manufacturing, which is fantastic. But a lot of times there's this big disconnect that isn't readily made available on what's being sold and what's actually implementable in a calendar year or in a couple of years. And the days of having investments that span 3 or 4 or 5 years, they're long gone. If a solution can't be realized in a couple of years in a relatively small period, it's really difficult for a large OEM in this uncertainty environment we're in to be able to invest in that. So I really caution different providers, instead of coming with this massive vision of 10 years where you want to take your product, come to us with what you have right now that we can implement tomorrow and provide value for our customers immediately, and then we can grow that relationship together to get to that future goal, but in a more transparent way.
Yeah, earlier I talked about what we used to call lights out manufacturing years ago, right? Which is really the introduction of intelligent autonomy and everything. And you look around this floor and you say, well, the technology's there now, right? We can do it. So I guess the next question for the panel is, how far are we really from true interoperability? And more importantly, like what's holding us back? And I'll start with Tracy and we'll go back around.
Okay. I mean, from our perspective, from a wireless charging perspective, interoperability is one of the strongest benefits of it. I mentioned all the different applications that you can use, but if you think about it, right now you have disparate systems and facilities, you have different charging systems, you have contact-based chargers that you have to maintain, so you've got resources there. If you put in a wireless charging infrastructure, you don't have to have as many, you can have transmitters located throughout a facility where the robots are going to be taking their path anyway. So instead of and they can charge when they get to that certain spot for just a minute, 2 minutes, 3 minutes, and that's called opportunity charging. And it's really good for the battery as well, for the health of the battery. So instead of having to pull a robot out of the workflow to go charge for an hour or two, you can just set up the stations along the paths, and whenever they get there, they can charge a little bit there. So, so that one of the benefits, but the interoperability again, it's like anything with any autonomous vehicle with a battery in it, you can charge with the same existing wireless infrastructure. And with the system, you also have software. So, the battery settings, the charging settings is all controlled with our software. And then it's also a fleet management system. So you can have thousands of them around the globe, and you can have one dashboard that you can control all your autonomous robots. And it gives you a lot of insights, gives you a lot of data analytics, it gives you alerts, a lot of valuable things. So when we talk to retailers that have a lot of equipment, this becomes very valuable because these new batteries are getting expensive for these robots, this lithium type based batteries. And so you really want to make sure that you're getting the use out of those batteries. It's a big cost center. And with the right wireless charging and the right insights and data analytics, companies can now start kind of changing the behavior of their forces and really getting the maximum length out of the battery. So there's a big ROI associated with it. It's probably one of the ROIs that's probably the last thing that you think about in facilities, but it's a big ROI.
Amir, you're next. Again, how far are we from true interoperability and what's holding us back?
So one thing I learned in my experience in robotics is that it's really hard to predict. The problem that we're trying to solve is one of the biggest problems that exist. It combines complex hardware with complex software and with industrial grade quality, and in an environment that really has no tolerance for any mistake and every issue. From my experience, it always takes longer when it comes to automation and robotics. So technology that get in consumer devices and other areas are much quicker to be deployed in these environments, while when it comes to automation, industrial applications, and especially robotics, it just takes longer. I believe that it will take somewhere between 3 to 5 years until we start seeing the first applications of physical AI. I'm not talking about the demo robot. I'm talking about something that reaches the quality level that my friends here need, right? Something that can work reliably 24/7 in a manufacturing line and to show immediate return of investment and resilience to the needs. The real revolution, and when it will come to size, is something that is hard to predict, but I believe it will be longer. It will be probably closer to 10 years until we see that technology really at the level that it can achieve, and the potential is huge. I mean, I expect that eventually all machines will be intelligent, that will all be connected, they will be all physical AI powered, and at some point smarter than us. That's what we want it to be.
Paul, from Ford's perspective, right? I mean, you have very structured and aggressive measures to get to full autonomy, intelligent autonomy in your many plants. Work very closely with all your plant managers. Talk about where you think, in your perspective, how long is it going to take to get there? And again, what's going to hold you back? What's holding you back now?
It's a journey. The concept of a true end-to-end digital twin is not new. It's been around for quite a while. And a good question to ask is the can versus the should. Can you create an environment that has that end-to-end control model and that has a true digital twin that's in real time controlling and optimizing the manufacturing environment, your whole environment? Sure, you could do that, but at what cost and at what level of resiliency would you need to be at to make it sustainable? What we're trying to do is find pockets where that is possible right now and go really deep and really far in investments in those categories. One that I love to bring up is the autonomous mobile robotics space. We're going very, very far in that and investing in technologies that bring those together in a synchronized way that can optimize our fleets and have that end-to-end control model to produce a better manufacturing environment for our customers and for our employees. The reason why I love that too, one of our biggest safety issues in our plants relates to manual PMHV traffic. It's a huge industry issue. And this is a topic that solves that problem, real tangible solution. It reduces the cost and complexity for our customers, and it utilizes artificial intelligence in a meaningful way to control a large fleet of these AMRs that provides value immediately. So it checks all the boxes in my book. Does it create value? Is it improving the cost and quality for my customers? And is it improving the safety and efficiency of my workforce? It does. And I want to go far with it instead of spreading ourselves too thin on a big picture goal that could be challenging.
Great. Wolfgang?
I think we have come a long way. Like we just talked about the vision, and when we started, there was like a lot of black boxes, software was bought together with hardware, okay? Guys from the shop floor went out and said like, oh, I like this screwdriver, or I like this robot, and they bought it, and software came with it, okay? And you had like a lot of silos and black boxes next to each other, and this is what motivated us to bring in that like unified platform to orchestrate all those different participants on the shop floor together. And like I said, it's been quite a journey. We reached quite a lot because we have that standard now, bringing all those different robots together. We see more and more like professional behavior in the market. We see charging technology coming in, getting stuff together. We see like customers understanding the pain point, since automation, especially in Europe and North America, is becoming more and more important. So we are not there yet. We are not there on the lights out black factory. We are not there yet with just plug and play. You can just bring something in. But we made huge steps, and it's step by step. Like we introduced that, for example, layout interchange format, where you can interchange maps in between mobile robot companies. Now, with the next version of the VDA 5050, we will have AGVs, so magnetic or virtual line-driven vehicles, and AMRs, so more intelligent robots, in the same layout, okay? And even another step of interoperability will be done. So it's developing, and the speed is picking up from my understanding, because technology, like you said, it's available and you have to get everything together. And due to more automation, the pain is understood better in the market and more people are investing into that field. But it's the most difficult field in, let me say, logistics, yeah? We see those big investments in all of supply chain, trucks, air freight, and all that is optimized. But those hubs where things are worked on, produced, repacked, they're the Wild West,
Yeah.
And you have to bring everything together, and it's dirty and it's difficult, but I see a huge development there, and interoperability is coming.
Yeah, I'm glad you brought that up, and to Paul's point too. I think, what we do is we introduce Industry 4.0 technologies to large manufacturers, and they implement those, right? And I've had the luxury of working with manufacturers to watch them try to adopt it. So the question I pose is, what's holding us back? Because the technology in many cases is proven, but for every specific application, whether it's bin picking or autonomous material handling, it's a very specific way you're implementing it in your plant, which requires engineering time, right? One of the things we've seen holding back is that sometimes just to put a proof of concept or a pilot together can take 3 or 6 months, finding the right engineering team, not disrupting production. Wait until production runs are done, so you got some time to actually test it out before you go in a full production environment. So, to Paul's point, it's a journey. It takes time, and it takes dedicated resources in engineering and technicians to work on these implementations. So,
well, and to build off that too, I always get really frustrated when we're in pilot purgatory for months and months with a concept that's ready to go, implementable across the board. And we've been encouraging our teams to scale relative to just continuing to try to chase the biggest and brightest thing. There's a lot of opportunity out there to replicate, to deploy proven technology and get more value out of the system than always trying to just have a new pilot going on at a plant. So there's a balance. You need to push forward, but also you need to realize the value that's available immediately and just scale it across the enterprise.
Very good point, Paul.
And I can just add there, because I was talking to mobile robot companies here, and we were talking about what is needed in the market, what's the next big thing, and I was like, hey, bring me hardware, reliable hardware with a solid software stack on it. So when we scale, we can ramp up tenants really quick, so we can really go out and produce. And I don't need that last 5% crazy driving. I don't think we just the market is. Problem is really having reliable hardware with reliable software and just then scale. And so then we don't talk about 10 or 20 robots, but 100 or 1,000 robots. And that's the world we need to go into. And we are very close there.
Yeah. So now I want to shift the discussion around what we call future proofing, right? If you've been in manufacturing long enough, you walk thousands of manufacturing plants like I have, you see a stranded piece of automation equipment, a robot, or a vision system that's no longer in use. And there's so much innovation, and it's moving so fast, the technology. I'd be really interested from the panel's perspective to tell us what companies should be doing to really future-proof their investments in autonomy, so that what they're investing in today doesn't become obsolete in 3 to 5 years. So let's start with Amir.
Yeah. So that's a real challenge, because if you adopt too early, you can get an immature technology, and that sometimes creates frustration. One of the robotic companies I'm working with told me that it's very easy to sell the first 5 robots, but it's really hard to sell the 6th one, right? Because companies see it doesn't work as good as they expect, the technology is not really mature, and that creates frustration and it creates delay because the same plant wouldn't install robotics again for a long period of time. So there's a real trade-off. I think the proof of concept and the pilot is very important. It's very important from an early stage to check that the solution can actually fit the needs of the specific application. But it's also important not to wait too much. I think we're in a process that is kind of like the industrial evolution. Manufacturers that will just wait and not implement the technology, they'll find themselves behind and unable to compete with others. So there's a thin balance between the two. And I've seen companies that are very good at implementing new technologies, taking them, but also being very clear on defining the line. And if it's not good enough, then it doesn't get in. And that's okay. Not all technologies need to be implemented right away. It has to be good enough, and it has to meet the industrial criteria that is needed.
Yeah, Paul, I was hoping you could talk about it because I know large manufacturers sometimes there's always a risk of investing in the wrong technology, and so I'm curious at how you're looking at that as well.
Sure. I mean, I could answer the technology question, but I think the real one is the culture and the people side. One case study I love bringing up is our relationship with your organization, the I4O Accelerator. So we canvass our plants to understand the problems that we're trying to solve. We focus more on the problems. What are we trying to do that's causing a negative effect on our customers or our partners? Then we go and we find the technologies that meet those needs. A lot of times people do it in the reverse. They walk around here and they see something cool and they try to fit it into an environment, and it doesn't end up going very well. It doesn't end up scaling like they want it to. So I would say the future proof is really to have a culture that enables it, that brings problems to light, and then goes and allows their employees to attend events like this with that problem list in hand and find the right partners that can plug in and come to a solution for you.
All right, Wolfgang?
Yeah, I can only agree what Paul said, and Frank, a little bit more technical side. I think you have to be king of your data. You have to find a setup in your architecture that allows you to keep your data, understand your data, and work with your data, and then like on a very flexible modular way, like adopt software and like building stones into that, you know, like have flexible systems that allow you to, like don't like buy black boxes and sell your soul to a single solution, but if you see like there's new like innovation out there you need that brings value to you, you can just adopt that very quick over standards, over standardized interfaces, and then you can get rid of technology that's not helping you anymore in a very like easy way. So very flexible, very model. I think that's something you really need to have a future-proof thing, because the idea to centralize innovation and be top of the game and everything, that's over. You can't keep up with the speed. You have to go around and find value for yourself that solves your problems and add them to your ecosystem and let them go out of your ecosystem and combine them to like the best possible setup for your company and your
Yeah, that lends exactly what Paul is saying. If trying to invest in flexible systems that are adaptable. If something doesn't work, you haven't lost out on the entire capital investment. So, Tracy, from your perspective?
Yeah, so I love all the answers that were given, and I especially love the comment about the POC purgatory, because that's what happens with a lot of customers. So I think that companies need to get out of that. They really need to get serious about evaluating. Designate a small team. Again, understand where some of the problem issue is. Understand what your problem is costing you, because obviously the solution needs to be less expensive than the problem. So that's the first thing. But I'm the only person up here on the sales side, so obviously my answer is going to be a little bit different as a VP of sales. But I would say, go for it. I'd say find a good vendor that you feel good with, that you've interviewed, that you've spoke with, that you have a good rapport, it's a good cultural fit. And then also find a vendor that is willing, that has the resources and is willing to do a lot of the work necessary to get those test pilots, up and running. Would be a smart move, for sure.
And one thing I'll add, we've been really exploring how do we become more asset light in our approach to automation. In the past, we would invest $100 million in a very rigid line that could do a couple of different things that are well defined. Now, with the advent of autonomous mobile robotic technology and other types of technology, we're able to see that in a very different way in terms of a CapEx versus an OpEx model. And it's unlocked a whole suite of opportunities to be able to deploy these at scale without tying up a lot of capital, especially in automotive, which has traditionally been a very capital-intensive industry where investment's been hard and product cycles have been long. And so thinking about that asset-light approach, it enables flexible automation and it enables it at scale quicker than we could typically do with a large CapEx purchase.
Paul just nailed one of the areas that I give advice to a lot of manufacturers is try to work with vendors that will be flexible to provide their technology in the form of a service. So what I mean is being able to, instead of purchasing the AMR or the vision system, can you buy it as a service over a 3-year period? And then you're shifting your investment from CapEx to OpEx, as he was mentioning. And if it doesn't work out or something more impressive comes, you're not married to the asset, you can then move on to the next technology. So you're now hearing robot as a service or inspection as a service. Those business models exist and they can be really beneficial for manufacturers as a way to adapt and be prepared for advancements in technologies a couple years out. So
it's really a win-win for both the manufacturer and the customer. The customer doesn't have to keep all these assets on their books, but then the manufacturer gets to sell another robot every 5 years or cycle this through on a subscription basis to their end customer. So I encourage more manufacturers of technology like this to look at those types of models. It's very advantageous for the end result.
Yeah, not to mention, I mean, a lot of manufacturers, it's easier to come up with operating budgets than capital budgets. So I want to see if there's any questions before I move on. Does anybody have any questions? Feel free to just raise your hand. We got a mic right here, and questions, thoughts, perspectives on the topic, intelligent autonomy. Sure, go ahead, announce yourself and your question.
Yeah, Rob Hoysgaard. I work with a company called Wheels.
Can you speak up a bit? I'm sorry.
We lease equipment. So
Okay.
I just want to point out exactly what you said, equipment as a service. There's also the leasing, because the leasing is kind of forced cycling as well. And
Correct.
it doesn't outlay a ton of capital.
Yeah.
So I just wanted to point that out as well as another possible solution.
So I can, especially we're doing a lot of projects here in US, but also in Europe. In Europe, that's pretty much the standard. And ROI is not the question anymore because you can always kind of work with leasing, and all the big projects we do, with big OEMs in Germany and Europe, are based on leasing hardware. Yeah, so that's something I was thinking of as well as he said,
Lease to own, lessens the burden on capital and also helps with depreciation of the equipment over time. Yeah. Maybe be switching out equipment, upgrading equipment. Very good point. Anybody else have a question?
I'll add one thing to that, and it's scalable too. If we enter a peak time where we need more assets, we can bring those assets in and cycle those assets out, particularly right now where there's a lot of reshoring activities going on in the United States, and there's just not enough people to fill all the jobs that we need filled. And so having that flexibility from a financial perspective and an equipment perspective allows us to achieve our goals of bringing more content to the U.S., while also being conscious to our shareholders.
Question over here. Your name,
Hi,
company?
I'm Tyler. I work for KUKA Systems. I was just over at the Siemens booth, and they were showcasing distributed manufacturing. How does distributed manufacturing play into this, where you have multiple different, potentially equally capable sites that could manufacture for you, and choosing which place to go with and how to be flexible there?
Who wants to take that one?
That's a big question.
So I'm very familiar with the whole distributed manufacturing model, and I love it. It's great for certain applications. It's challenging for complexity environments where you have a lot of different models, you have a lot of different features, but I think there's definitely a time and a place for it. I struggle to see it in automotive as much, but in some other industries, I see a lot of potential.
Yeah, I've worked with quite a few companies that have adopted that. Sometimes it's for very specific operations, and it can be difficult if you need, obviously, dry room, clean room, like a battery manufacturing facility. But where you have heavy equipment and or you have need for periodic deployments, like I have an example, there's solar panel companies that are actually manufacturing the solar, not necessarily the panels, but the panel assemblies closer to the location that it's going to be installed in shipping containers, because it's far less expensive than manufacturing periodically and then storing and then shipping wherever you got to ship for the installation. So I think it based on the use case is where it makes sense. Any other questions? Raise your hand if you have a question. Well, I have one that's that I wanted to hold off for the last, because I think everybody is always interested in what's next, right? So, I'd like to ask each panel member from your perspective what you see is that's coming next for intelligent autonomy that you're particularly excited about. Let's start with Paul.
Well, there's so much. Since it didn't come up, I got to bring up humanoids, because that's probably 60% of the questions that I
surprised there wasn't a question about humanoids yet.
So I'd love to start out by saying I'm not anti-humanoid. I'm just pro-value, and I don't see the value from an immediate perspective in that space. But I think we should be working towards it over time. A great example I love to use is that you see these proof of concepts of moving a box with a humanoid from one line to another. Well, in a practical perspective, the amount of value you're creating by using a very expensive, complex machine to move that box from point A to point B might not be the right use of the technology, use of the capital to do that mission, as opposed to just a traditional industrial robot that could do the same thing today at a far greater value. But I do look forward to a future where we could have a serious conversation about humanoids and their developments in a real manufacturing environment. But in terms of what I'm most excited about, it's seeing so many younger people getting involved in robotics to be able to fuel a whole new generation of robotics engineers and people that are able to really drive our industry forward. I had the opportunity earlier today to walk through, there was an area, or it was an education zone here, where there was a bunch of different schools and robotics teams competing together and working together towards a common goal. And it's so inspiring to see, and it's driving the future on a day-to-day basis. So the people side, I always say from a manufacturing innovation perspective, there's three things that drive it. There's the right strategy, the right technology, and the right people. And I love focusing on that third one because it's what enables us to succeed as a company, as an industry, and ultimately as a large conglomerate of people to work towards this goal.
The right people and the right humanoids.
Working together.
Wolfgang, what's next? What are you excited about?
Humanoid? No.
I'm happy to take that.
No, I think really a lot of things coming together now, and I think the market for mobile robotics is really about to scale. The industry is getting more and more professional. A lot of things coming together. We have standards. We have, in different aspects, are being developed. We have very professional players in the market. Integrators are picking up. It's really coming together. There's going to be a brutal consolidation, like looking at all the different hardware suppliers in North America, in Europe. There's going to be a lot less in a couple of years, but I think the market is really like jumped over that innovation gap into that main market, and it's really about to scale. And I hope in a couple of years we don't need to talk about 10 or 20 robots, but really 100 or 1,000 robots in installations. I think we are close. A lot of technologies are there, and more things are coming together. So that's what I'm excited about, not the one single innovation.
Yeah. Tracy?
Yeah, me too. You know, I've been in this business for 20 plus years, and I'm amazed at how fast the technology is moving right now. And we see a lot of it because of the business that we're in. But, you know, we're certainly excited about humanoids as well. You know, if you look at a lot of humanoids, they're either tethered or, you know, they have to do battery swaps, you know, things like that. But really, you could put a wireless charging system in there. For example, you could put a couple, you know, charging coils in the feet and just have them stand on a mat, right, and charge all day long, so you don't have to pull them out of the workflow. We're also excited about all the quadrupeds that are coming out. You see those really primarily with some of the delivery companies, the global delivery companies. A lot of these companies are going to be using drones for suburban deliveries, and they're going to be using you know, quadrupeds for urban deliveries. So that's exciting for us because obviously that's a bigger market. But you know, what we're seeing now is it's almost like moving really fast as we're seeing, you know, our customers want to be able to charge other robots with robots to really make it autonomous, right? And so that's coming as well. We're working on that today.
Amir, from your perspective?
So for me, the potential for physical AI, I think, is the most exciting thing, and I think in a few years that's going to be a real revolution. When you see today what a very simple model, large language model or large vision models, how much smarter they are these days, that you can give them a picture and they understand much more than anyone can do. They come prepared and they've seen the entire internet, and they're so more smart than what we do. So the potential of getting that into machines and making machines so much smart, I think that's really the next biggest revolution. And the day is not far when we'll have machines that are really smarter than what we are and that can do better than we do. Not just replacing humans, but really doing the task better, more efficiently, in a much safer way. It's coming up.
Well, you know, I had one thing. We're at a really exciting time in the automation industry. Over 120 years ago, right down the road from here, Henry Ford revolutionized the American automotive market by bringing an all-new way of putting together a car, unlocking the first mobility revolution and freedom for people to move about all across the world. We're on the cusp now, 120 years later, of the automation revolution, bringing artificial intelligence together, bringing low-cost, affordable, flexible automation together in order to increase quality, increase resiliency, and ultimately deliver more value for our customers like we've never been able to do before. And that brings me a lot of pride, coming from Metro Detroit, the birthplace of the modern American automobile, birthplace of the affordable global automobile, to be right here at Automate talking about the next generation of automation and what that's going to mean for us collectively. So really exciting for things to come.
Yeah, if I can back on that is in closing, I mean, what we're seeing in artificial intelligence, I mean, it's already in use today, right? For connected worker platforms, AI-based pattern recognition software for inspection and error-proofing manual assembly operations. I think the promise for AI machine optimization, process optimization, you're already seeing it in tool path optimization, and I think you're going to see it in material selection for lightweighting vehicles and other products. AI supply chain optimization we're trying to work on with Ford and others, where you're really doing demand forecasting and inventory and material purchasing optimization all the way through your supply chain. I think we'll see a date where AMRs are not so sophisticated. Maybe they don't even have vision systems on it, and you have a central control that allows for lower cost robots. And then the AI tools that we have for product development. Sometimes we overlook, you know, all this innovation for manufacturing, but we're going to remember product development's a part of the manufacturing process, and we're starting to see incredible use of AI for optimizing the design and production of injection molding tools like Atomic Industries right here in Warren, Michigan, speeding up by using mold flow analysis and the art of the science to design and engineer and make tools in a matter of a few days instead of months, right? So this innovation's all around us, and it's really important that manufacturers here in the U.S., particularly right here in Michigan, are really investing the time to test and demonstrate and implement. So again, I want to thank our panelists. I want to thank Automate, E3 for having us today. And please give a round of applause to our panelists. that concludes our panel.